Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hey guys, welcome. So, I'm just in the final process now of getting the camera and telescope set up, and we're going to do some deep sky observing here tonight. Right now, I'm just trying to find my guide star and get the camera ready to rock and roll. So, bear with me here while I get the final steps in place. Okay, we've got one star there. I don't know if that's really the one I'm looking for. I'm looking for a particularly bright guide star that should be near this field of view. I'm gonna use the star I can see in the main camera window here. I gotta position that a little more centered in order to see the guide star I'm looking for, according to my sky chart here. Looking on Sky Safari Pro. Should probably also bring it down in the view a little more. The galaxy we're going for right now is NGC 3628 in the constellation Leo. This is a spiral galaxy. Magnitude 9.17, according to Sky Safari Pro, 35 million light years away. Bring that up a little bit. Got to take out the deck backlash. I've been going south, south, south on it, so the galaxy is going to have to be a little bit in a weird position, way off center in the view, in order to properly position the guide star that I really want. Maybe I could go with one of these fainter stars, but I'll get better results if I go with a brighter one. Now, let's see if the auto guider's got the picture I'm looking for. Nope. Don't quite see the star I'm looking for. At least I don't think I do, unless that is the magnitude 7.1 star. I'd be surprised if it was, but because if it were, I think it'd be a lot brighter than it is. Let's see here. It's possible I need to rotate the camera a little bit. I'm not sure if that's the right way or the wrong way. Let me see what the orientation is. So in the main imager window here, the larger window, I've got a star here and a star here. These two stars, I think, need to be a little more in line with each other, less of an angle. There's still an angle to them. I'm looking here on Sky Safari Pro to see my planned shot, and in the planned shot these have less of an angle between them, a shallower angle. Gets me the shot I want. Now let's try that with the guide, the auto guider. See what we get. There we go. Now we're in business. That's what I'm aiming for right there. That big bright star. That's a beautiful guide star right there is what that is. So I can use this to calibrate the camera. So now I'm going to position, based on what I see in the auto guider window, this really bright star right there. We're going to move that down into position and calibrate the instrument. Basically teach the telescope which direction it needs to move in order to move a certain direction in the image. And things are a little wonky because I've got the camera rotated. It's designed to rotate with the adaptive optics unit on here. You have a very tight field of view, and so you need to be able to rotate the camera to find the guide star you're looking for, like I just did. It's designed to do that. Okay. Let's see, let's go this way a little more. I need to give it plenty of runway because it's going to want to steer the telescope in a north and east direction to calibrate it. So I need to first take out the backlash. Basically prime the gears. Okay, so they're primed. Now we can go down to a much shorter exposure. Let's do 1/10 of a second. Could even do probably a fraction of that. Let's do 0.05 seconds. Just so we don't see any other stars. There we go. I just want that one bright star sticking out for it to track on. And now we're going to calibrate the drive. X-axis for 5 seconds, Y-axis for 8 seconds. That's good. So it's going to move the drive in both the X and Y-axis to figure out the orientation of the camera. In order to be able to properly control the telescope. Okay. While it's doing that, let me load up the chat on my phone here. Yes, this is on an actual telescope. This is my 8-inch LX200 Classic with an SBIG ST2000 XCM camera and an A07 adaptive optics unit. Okay, so let's look at the drive calibration results. So as expected, it's not symmetrical around the Y-axis because of the backlash, so I manually copy and paste to fix that. And then click OK. So that looks pretty good. So now we need to prime it in the north direction again. Well, I say that. It's not super necessary at this point. At this point, we're going to calibrate the adaptive optics unit. Before I click that, though, let me exercise the adaptive optics unit. First of all, AO settings. Let's... where's the button to reset? Here we go. Center. Yeah. Make sure it's centered. AO settings. Exercise both axes. Okay. I don't know if you guys can see that. Probably not. Recenter it. Okay. Take an image. And then we're going to calibrate. We're going to calibrate the adaptive optics unit. And it doesn't move the star nearly as much, but it's moving the mirror, the adaptive optics mirror, to train itself and how it moves. And it's going to try to keep the star centered now based on moving that mirror, and only move the drive when necessary to get it back within the limits of what the mirror can handle. Alright, so with that done, I will now move the star back up to the top of the field of view to give myself the maximum possible spacing between the galaxy and the bottom of the image. Because the galaxy is going to be at the bottom of the image. Okay, I need to move the telescope this way. So, to deal with that, and to get the best possible image, I really need to position this star so that, come on Skyspire, really top left would be best. So those of you just joining us, we are working on imaging NGC 3628, a spiral galaxy in the constellation Leo. So I actually, well, okay, I probably don't want to go quite that way. I'll go this way. Yep, I'm sort of flying in a diagonal direction here, trying to fly the star over to the top right corner. So this bright star here is going to be our guide star we're going to track on to keep everything centered up. That's what the adaptive optics unit will actually use to compensate for both drive tracking errors as well as the atmosphere. There we go, that's got it right where I want it. So now it's at the top left. Can auto guide probably at an even faster rate. Let's do 0.02 seconds. Yeah, that's really fast. So it's guiding at 20 hertz right now. 20 times a second it's making a correction. And we're going to start auto-saving these images. We're going to set the main imager to 1:1 binning using every pixel getting maximum resolution. We're going to set the exposure length to 5 minutes. We'll do an auto dark subtraction, that's fine. And go. So now it's going to take the first image of this galaxy, the first real image. The sort of the initial acquisition image is just lining things up. Shows the galaxy, but it's very faint and you can hardly see it. It's just a smudge. A light, faint smudge here at the bottom right of this image. This image was just a few seconds of an exposure just to get everything lined up. It's actually similar to what you would see by eye if you were looking in the eyepiece with averted vision from dark skies. With this telescope, you might just see this galaxy, but it would be very dim and it would look very fuzzy, and it would basically look like this. This is what your eye would see in the eyepiece, because our eyes can't collect light for many minutes at a time. Oh, fire's protection, go away. Everything's good. So our eyes process light instantaneously. The camera can collect light for, several minutes at a time. And that's why it can see much more detail than our eyes can. So we're now compensating for the effects of the atmosphere and drive issues at a whopping 20 hertz, 20 corrections per second. That's half of the maximum speed of this autoguider, actually. The maximum speed is 40 hertz, I believe. So this will be some of the best corrected images I've ever taken, in theory. It's rare that you can find a guide star that's this bright close to the field of view, kind of perfectly positioned to be able to get the galaxy in the frame. Usually you have to settle for a star that's 10th or 12th magnitude, and that's decent. I mean, you can still do that. That's way dimmer than anything you can see by eye. Keep in mind, these stars are normally much dimmer than anything you can see by eye. In this case, this star that looks really bright to the telescope at 7.1 magnitude 7.1, that's actually the dimmest star you can see by eye, or one of the dimmest. A trained observer under dark skies with averted vision can see down to about magnitude 7. So this is about as dim as you could possibly see with your eye. Think of the faintest star you've ever seen. That's basically no dimmer than this star right here. And to the telescope's camera, it looks incredibly bright, even in single-second exposures or sub-second exposures. We're taking exposures here that are 0.02 seconds long, and it's still easily bright enough for the autoguider to keep a lock on it. So that's pretty good. But that's kind of why I've positioned the galaxy where it is, so that we can get this guide star and get the maximum possible guiding and adaptive optics, the adaptive optics unit working at its maximum speed. 10 or 12 straight days of rain here in Hong Kong. Sorry to hear about that, Flying Tiger. Yeah, I'm surprised we've got clear skies here. I mean, it is summer, or approaching summer, and here in Florida, it's incredibly, brutally hot out tonight. It's very warm and muggy. Feels very, very warm. Fortunately, the SBIG camera is doing a good job of chilling down the CCD to -5 degrees Celsius, even on a nice warm summer night here in Florida. But yeah, I want to get into talking about some stuff. First of all, thank you again to everyone for joining us here tonight. Hopefully we'll get some good observations of this galaxy. I don't know how well the weather's going to hold out for the rest of the evening. It's supposed to stay clear until about midnight here, so I'll probably wrap it up in a couple hours. But hopefully we can get some good images here of some of these galaxies in Leo. And wanted to mention, I'm currently building another website. If you've seen my recent videos talking about Starlink, we're going to talk about that some more here tonight. But I'm also building another website, sort of the main website for this channel. One of the purposes of that is going to be to provide a live view of where the telescope is pointing in the sky with that sky chart program that I wrote. So you'll be able to see where the telescope is pointed in my local sky, where that is relative to my horizon, and also be able to provide an ability for you, the viewer, to give not only feedback but actually control. The idea being that members can submit targets for viewing to the telescope and basically take control of the telescope. So you'll get to decide what we get to view next. So I'm working on building that out. Also, it should allow me, this is sort of maybe a future feature, maybe not a launch feature, but right now these images are basically just raw images when they come down. I might do an auto dark subtraction to take out the hot pixels, make it a little more palatable for live viewing. But really, it would be nice to use a proper dark library, a whole library of dark frames. So right now what the camera's going to do is it's going to download this light frame. It's downloading this first exposure, 5 minutes long, of this galaxy. And then it's going to close the shutter and take another 5-minute exposure with the shutter closed deliberately. There we go. That's a really nice looking picture just based on the... Ooh, yeah, there's that galaxy. That's nice. It's a nice edge-on spiral, and you get a really nice dust lane going through it. First time I've ever done an image of this particular galaxy with this telescope and camera combo, and especially with the adaptive optics unit on here. There's 2 other galaxies in Leo that are near to this one, and normally, most of the time, if you look for amateur images of this galaxy, you'll see all 3 in a single image. The field of view of this camera and this telescope is so tight, you're looking with so much magnification effectively, that you can't fit all 3 of the galaxies in there. You can only fit them in one at a time, even though they're relatively close together. You're looking here at a very tiny portion of the sky. So this is NGC 3628. And you see all these colorful pixels here. These are all hot pixels. These aren't stars. The stars are more obvious, the circular, bright objects here. And just based on how small those stars in the image, it looks like everything is well in focus. I expected no less. I did focus on the star Regulus in the same constellation just before starting the webcast, so the telescope didn't have to travel very far to reach this object. So I was hoping I wouldn't get mirror flop, and it looks like I'm fine on that front. No mirror flop to speak of. When you slew this telescope over a large portion of the sky, sometimes the mirror can flop around a bit, and that adjusts the focus for you, and you have to readjust the focus when you get to your destination. Not the case tonight, though. We had a nice bright star close enough to this galaxy that that's not an issue. So right now, like I said, it's taking what they call a dark frame. The shutter's closed, and it's taking us another exposure at the same length, and it's going to have the shutter closed, and so the only thing present in that exposure is going to be the noise in the image. Primarily the hot pixels, all these colorful pixels. These are basically defective pixels. Every CCD has them, but when you're taking very, very long exposures, multiple minutes in length, of these very dim objects in astronomy, the hot pixels, the defective pixels, stand out much more than they would in a short exposure image. You won't see this in daylight levels of brightness if you just do a very short exposure of some bright object. You won't tend to see hot pixels like this. But when you do these really long integrations of light, these really long exposures, they stand out like a sore thumb. So to get rid of that, we close the shutter and we take an exposure with the shutter closed. However, that'll eliminate 99% of them, but there's still 1% that can crop up in the middle of the exposure, or sometimes they can just fluctuate a little bit, going on and off, whether they're on or off. Basically, the way the CCD works, this is a single shot color camera. Every pixel is assigned a color, and it has its own built-in color filter, red, green, or blue. That's why these hot pixels are red, green, or blue, because it's only a single pixel that's defective. But it's actually a matrix of pixels that will decide the color in the image normally. But when one of these pixels is defective, if it's a red pixel, for example, it'll light up bright red, because that's the only pixel lighting up. The other neighboring pixels, the green and the blue pixels, aren't lighting up. And so it shows up bright red in the image. But sometimes you'll get a pixel that is sort of transiently faulty, and so taking a single dark frame isn't a bulletproof solution. And you can even start to develop new hot pixels if you're doing a long imaging session. I've seen that before, where they crop up and they weren't there initially when it took the initial dark frame. And there's also the background noise level that just aren't just hot pixels, but just this background thermal noise. It is holding a set temperature right now. It's holding -5 degrees Celsius very precisely, because you want the dark frame to be at the same temperature as the light frames. The background noise level is determined in large part by the temperature of the CCD, so you want that to be held as constant as possible, and this camera can do that. But as you can see, behind the hot pixels, this other grainy noise, it's kind of random. So a single frame exposure of the single frame dark containing that noise isn't really going to be a perfect solution. That noise is going to randomly change. It's thermal noise that's just randomly going to change like static in the background from exposure to exposure. So to really correct for it properly, you need to have a whole library of dark frames, multiple dark frames. This software is not really designed to do that on the fly. You can collect the images, but it won't subtract a dynamic dynamic library of dark frames on the fly, really. At least I haven't figured out a way to make that happen. So it would be nice to have my own software that sort of does my own calibration process, where it's subtracting based on a whole library of dark frames I've collected before the show, to do a better subtraction, subtract more of the noise, and get a better image. So here's the resulting image. You can see there's still some hot pixels hanging out here. It's not a perfect solution. It's good. It's way better than it was, but it's not perfect. So that's one of the reasons I want to have my own site where these images can be processed on the fly for viewers to see. So I would continue to do live streams on YouTube like this, and you would continue to see the raw images. But I probably wouldn't even do this single dark frame subtraction, because that's really just not a great solution. It's a solution, it's just not a great one. So it would be better to subtract a whole library of dark frames. And it would be better to have dynamic subtraction or calibration of flat fields. These circular donuts you see here, this little black spot here, this little black spot here, this big fainter, I don't know how well it's coming across on the stream, but there's a fainter donut right here. These are all dust motes on the CCD or on the adaptive optics unit. And you can calibrate for those too by taking a picture of just a flat field of light through the telescope and be able to basically compensate for that as well. However, again, that's not really easy to do here when we're taking images at night and just trying to live view this object. The software's not really set up for that. It does have an auto, I believe it does have an auto flat subtraction mechanism, but it's not a convenient way to do things the way it's set up. So the idea would be that on my site you could continue to view these live streams on YouTube, but you're going to get an inferior quality image. You're going to get a lot more hot pixels in the image that you're seeing. You're going to have all these donuts, these dust motes that are on the CCD in the live images. But if you go to my website, members will get to see properly calibrated images on the fly. I would write a Python program to basically do automatic subtraction from a library of darks, automatic calibration from a library of flat fields, and maybe even automatic, I don't know about automatic HDR, maybe we could do that. We could look into it. But definitely some automatic calibration and processing of the images to get the best possible quality images coming in live. So it would be basically a separate view from this. I don't know how I'll handle things like audio exactly. I might just have people just load up this webcast in the background, but watch the web page for the actual images. That might be the best way to do things. That way everyone's on the same page in terms of the audio syncing, but what you're getting is a different experience on my web page versus YouTube. So those are just some thoughts I had, and I'm still working on developing the site, but I've been playing around with setting up the system for the database of memberships, and basically setting up the login and log out process. So that's working at this point. Still got some more to do. The big deal is going to be, of course, setting it up so that it's showing a live view of where the telescope's pointed and sort of doing live image processing of all this stuff. But the images I take here tonight I can use as sort of a practice run and pass that through the software and see what happens. So yeah. Thanks, guys. Yeah, that is a great looking galaxy, isn't it? I'm really quite pleased with that dust lane and how all of that looks. It's quite good. I do want to see if I can keep this in the view. Arc. I keep zooming in on the guide star here. Reason being, I just want to keep tally on it. If something should happen, if a cloud should come over, it could obscure the guide star, and that would not be good. If it loses track of the guide star, it can start chasing its own tail, basically. So I need to keep an eye on that. Doesn't have to be quite so large now, but wrong magnifying glass there. Shrink that back down. Just makes it easier to move when the window's a little bigger. There we go. As you can see, that guide star is being held perfectly in place, and these stars here are very, very tight, very, very small, so that indicates good focus and good tracking. So image number 2 is coming in. There we go. So the other thing I want to talk about tonight is Starlink. So for those of you guys who haven't already checked it out, please check out my previous videos talking about this, showing what the night sky will look like once the SpaceX Starlink satellites are fully launched. SpaceX is planning to launch 12,000 low Earth orbit satellites to provide high bandwidth, low latency internet all around the world. And obviously this is going to have some impacts on the number of visible low Earth orbit satellites, especially early in the evening, just after sunset, and just before dawn. However, from locations that are close in latitude to the inclination of the satellites, which is 53 degrees, so people living close to 53 degrees north or south, during the summer months, you will see these satellites all throughout the night, from sundown to sunup. They will continue to be in sunlight, reflecting sunlight, and continue to be visible. This is going to have the most serious impacts, of course, on long exposure photography, like what we're doing here tonight. Because if a satellite streaks through the view, it's going to show up, even if it's a relatively dim satellite, even if it's a satellite dimmer than anything you can see by eye. Keep in mind, every single star you're seeing here in this image on the right these are stars that are all dimmer than anything you can see by eye. To the eye, this entire field of view just looks blank. You can't see anything. It's only with the telescope that we can see any of this stuff. So a naked eye bright satellite, even one that's at the limits of human vision. Again, keep in mind the star on the left here that it's being tracked at a very high speed, very short exposure, that's the limit of human vision right here. So even if these satellites are at the very limits of human vision, they'll still be so bright to this telescope that a very short exposure would show them. And with 12,000 of them in orbit, they're going to be filling the sky for many of us. Even those of us at lower latitudes, where they will go into Earth's shadow, generally speaking. During the summer months, it's still going to be a problem because they won't go into shadow as quickly. And in my case, for example, here in Florida, during the summer right now, they would still be visible even right now to the north, all the way into midnight and beyond. They'd be visible throughout the night in the north, though for most of the sky, the sky will be clear most of the night. But again, for those living at higher latitudes, they'll be visible all throughout the night during the summer. During the winter, you're in a much better position, you're in a much better situation, that they'll only interfere with the sky early in the evening and early before dawn. Late into the evening, they won't be visible at all, because they'll be in Earth's shadow. So, for visual astronomy and optical astronomy, that's obviously a better situation. But some thought I was perhaps being uncharitable or unfair in my analysis, or giving too much ammo to SpaceX haters, or people concerned trolling. I thought my analysis was pretty fair, pretty even-handed. I was not making declarations that astronomy as we know it is coming to an end, or it's the end of astrophotography as we know it. That's not true, but it is going to have an impact. And I'm not the only one who thinks this, and it's not just amateur astronomers saying this either. Here's a statement published today from the International Astronomical Union. These are professional astronomers, and they're in charge of things like the Minor Planet Center that monitor for potential incoming asteroids, so rather important people. The IAU statement on satellite constellations. I'm just going to read it here. Over the past decades, considerable effort has gone into designing, building, and deploying satellites for many important purposes. Recently, networks known as satellite constellations have been deployed and are planned in ever greater numbers in mainly low Earth orbits for a variety of purposes, including providing communication services to underserved or remote areas. Until this year, the number of such satellites was below 200, but that number is now increasing rapidly, with plans to deploy potentially tens of thousands of them. And just my own interjection here, SpaceX has, of course, already deployed the first 60 of their Starlink constellation. That's what's kicked off a lot of these discussions. It's no longer hypothetical. It's now a reality, and it's quickly going to become more of a reality. So, in that event, going back to the IAU statement, satellite constellations will soon outnumber all previously launched satellites. Indeed, I'm going to interject again here. There was an analysis performed by, I forget his name, I'm not going to try to get it wrong here, but the astronomer who got one of the first, maybe the first video of the Starlink satellites. You see it all over the place. It's very popular on the news sites. It's that black and white video of the string of pearls, the string of Starlink satellites going through the image, and there's like a timestamp in the video. That same guy did an analysis showing that once Starlink is launched, it will make up the majority of low Earth orbit satellites, not counting other constellations. There's still other companies planning similar things, and they'll have their own constellations. But just looking at it based on satellites that are up there right now, if Starlink were fully launched today, it would make up the vast majority of satellites in low Earth orbit, like 3/4 of all low Earth orbit satellites, somewhere around that vicinity. So, going back to the IAU statement, the International Astronomical Union is concerned about these satellite constellations. The organization, in general, embraces the principle of a dark and radio-quiet sky as not only essential to advancing our understanding of the universe of which we are a part, but also as a resource for all humanity and for the protection of nocturnal wildlife. We do not yet understand the impact of thousands of these visible satellites scattered across the night sky, and despite their good intentions, these satellite constellations may threaten both. The scientific concerns are twofold. Firstly, the surfaces of these satellites are often made of highly reflective metal, and reflections from the sun in the hours after sunset and before sunrise make them appear as slow-moving dots in the night sky. Although most of these reflections may be so faint that they are hard to pick out with the naked eye, they can be detrimental to the sensitive capabilities of large ground-based astronomical telescopes, including the extremely wide-angle survey telescopes currently under construction. Secondly, despite notable efforts to avoid interfering with radio astronomy frequencies, aggregate radio signals emitted from the satellite constellations can still threaten astronomical observations at radio wavelengths. Recent advances in radio astronomy, such as producing the first image of a black hole or understanding more about the formation of planetary systems, were only possible through concerted efforts in safeguarding the radio sky from interference. So I do want to make another interjection here to point out the fact that Elon Musk has stated that he's asked his team to take a look at reducing the albedo, the reflectivity of these satellites in future versions, so that in the future when they launch these things, they won't reflect as much sunlight and they won't be as shiny and they won't be as bright. And I commend that effort, and I hope that effort is successful. But we still don't know to what extent the reflectivity will be reduced. We know that they're currently raising the orbits of the 60 Starlink satellites that have been launched so far. Actually, side note, apparently 4 of them had trouble. I don't know if that trouble's been resolved yet, but 4 of them initially had trouble responding, not necessarily responding to commands, I don't want to put it that way, but they seem to be left behind. They aren't raising their orbits like the rest of them are. They might have had a problem with their ion thruster that they use, the Hall effect thruster. So, I mean, it is kind of unusual to see a Hall effect thruster using krypton gas instead of xenon, but it's cheaper to do it that way. So they are sort of forging into some new territory here, so it's not totally unexpected that a few of these satellites might have trouble initially. But I would assume that they have probably some alternative thrusters with conventional monopropellants that they might be able to use to deorbit them if they have to, if the ion thruster system doesn't work. So I wouldn't be too concerned about them going out of control or anything like that, but it is interesting to note that a few of them seem to be lagging behind. But the rest of them are raising their orbits to their final operational orbit, around 550 kilometers. They were launched initially into an orbit around 400-something kilometers. So as they raise higher, their magnitude is going to diminish, or their brightness is going to diminish. The magnitude number actually increases with diminishing brightness. Bottom line is that they will get dimmer as they raise their orbit to their operational altitude. I think Elon Musk has pointed this out, some others have pointed this out for sure. But it's important to note this is not the only orbital altitude they plan to use. One of those altitudes is actually even higher, over 1,000 kilometers, and I do think those satellites will have the least impact, visibly at least, by eye. They're going to be the dimmest. Again, to the telescope, a telescope like this would probably still see them. In fact, I can almost guarantee it. Unless they make the reflectivity extremely low, this telescope should have no trouble seeing the Starlink satellites at 1,000 kilometers altitude. It won't matter. They'll still be there. This scope's sensitive enough to pick that up. But at least by eye, those will have less impact. However, there's a third orbital altitude currently proposed. According to the Wikipedia, that altitude's going to be lower than 400 kilometers. Somewhere around, I think, 340. I'm going off the top of my head, so please don't hold it against me if I'm wrong on that. But off the top of my head, I think it's around 340. So it's going to be lower than the ones that were launched in terms of their initial orbits, therefore brighter. Now again, they are going to try to diminish the reflectivity, and hopefully that means it'll have less of an impact, but it's going to be combating the fact that they'll actually be lower. On the other hand, lower also means a lower footprint of visibility. There will be a smaller area of Earth that you can be standing on and see any given satellite at that altitude. So there's that as well. But still, I just want to make the point that just because these satellites are raising their altitudes and others will to even higher altitudes, that's not going to necessarily be the case for all of them. Some of them could be in a lower orbit as well, and those will be potentially the brightest. Alright, going back to the IAU statement. The IAU is a science and technology organization stimulating and safeguarding advances in those areas Although significant effort has been put into mitigating the problems with different satellite constellations, we strongly recommend that all stakeholders in this new and largely unregulated frontier of space utilization work collaboratively to their mutual advantage. Satellite constellations pose a significant or debilitating threat to important existing and future astronomical infrastructures, and we urge their designers and deployers, as well as policymakers, to work with the astronomical community in a concerted effort to analyze and understand the impact of satellite constellations. We also urge appropriate agencies to devise a regulatory framework to mitigate or eliminate the detrimental impacts on scientific exploration as soon as practical. The IAU's Commission B7 Protection of Existing and Potential Observatory Sites welcomes the opportunity to work proactively with everyone involved in these efforts. And they have some footnotes there and where to go for more information, contact information. So you can check this out on iau.org. If you just search for IAU, capital I, capital A, capital U, Starlink, you'll find it. I'll put the link in the video description when the show's done. So, yeah, there's a pretty strong statement there. I would dare say that statement is a lot stronger than anything I said in my previous videos, where I tried to be very fair to both sides of this argument. But these professional astronomers are saying in pretty clear terms they want regulatory authorities to step in and take control of the situation. So, at the moment, these satellites appear to have been approved by the FCC. In fact, they have been approved by the FCC. I don't know what other approvals they had to go through, but it doesn't look like they had to go through much, at least in terms of an analysis from an impact on astronomy standpoint. Mostly just an impact on the radio frequencies that they're using. So, Space News has an article as well, published today, saying little legal recourse for astronomers concerned about Starlink. I haven't read through this article yet, but yeah, it's generating a lot of discussion, as you can see. And so this is why I set up the webpage that I set up, so people can get a real analysis of what this proposed constellation of satellites would look like in the sky. So you can go to howmanystarlinkswillfillyoursky.com. Link will be in the video description, and you can generate a sky chart showing what your sky would look like right now if Starlink were fully deployed. You can also edit the proposed constellation. You can change the altitude of each orbital shell, the inclination of each orbital shell. I added that recently. I know that wasn't there when I initially set the site up and made it live, but it's now there. So you can now alter the inclinations to simulate potentially other constellations, proposed constellations as well, not just SpaceX. And you can also, of course, change the altitude of each orbital shell and the number of satellites within each orbital shell, as well as the number of orbital planes in each orbital shell. I set up some default values there that are hopefully close to what SpaceX is proposing, although I think I have a number of orbital planes that's too high. It doesn't matter, you can change it to whatever you want. You can also export a TLE file, basically standardized orbital elements for satellites, based on what my program and my website generates. So you can, again, customize the constellation to your heart's content, and then export it as a TLE file that you can import into other existing software to visualize these satellites in orbit around the Earth, both from a ground perspective and from a perspective of an observer in space. And you can see what that looks like. And I'm just doing this to provide facts and evidence so that people can make an informed decision about what they think about this. So they can see for themselves how many satellites are going to be up there, what time they're going to be visible, how time of year is going to affect their visibility, all of these factors. So I think for those of us here in Florida, the impact will be not too severe, to be honest. This is just my opinion. I'm not too concerned about it myself for my own observing as so much, only because, again, being in Florida, even in the summer, most of the sky will be clear of them most of the night. Additionally, Florida, being Florida, the weather tends to be the worst during the summer. We tend to have our best weather in the winter, with the clearest skies in the winter, and that's when these Starlinks are going to have their least amount of visibility. They'll go into Earth's shadow earliest in the evening and be done. And that'll leave most of the evening available. However, even then, if there's, a transient event, maybe an asteroid passing by Earth and it's only visible in the early evening hours, it's still potentially going to interfere or produce way more streaks through an image than would otherwise be the case. So it's not without consequence. And that's the point I'm just trying to make, is that although some might be overblowing the ramifications for astronomy, and I'm not saying IAU is, I definitely think their statement is fair, but, people declaring it's the end of astronomy as we know it, it's just going to ruin everything. It's not really true. Even for people who live in latitudes close to the orbital inclination of these satellites, yeah, it's going to ruin their summers. Their summer night's going to be filled with these satellites all night long. But at least you'll still have the winter. I mean, it's not much of a consolation, but it is one. And like I said, for those of us in Florida, we're lucky in that the impact shouldn't be too severe for the most part. But, to some, even, moderate impact in the early evening hours, that might not be acceptable to a lot of people, or they might want to voice their concerns about that. So that's why I'm providing this information. So you can see for yourself from your own location. Just plug in your latitude and longitude. East longitude is positive on my website. So west longitude, those of us here living in the Western Hemisphere, it's negative numbers. And you can see what your sky would look like right now, filled up with all those Starlink satellites. You can also see red dots representing existing satellites and how there's not nearly as many. So for those of us joining late, yeah, we got a galaxy in Leo that we're imaging right now. This is, what is this? It's not one I'm accustomed to imaging. NGC 3628, edge-on spiral galaxy in the constellation Leo, and its distance is about 35 million light years away. Oh, I see Redhead, you posted the link to Space News. Sorry I didn't get to that link soon enough. I went ahead and proved it there. I was yammering on, so I didn't see that you posted that. So yeah, you guys let me know what you think in the chat about all of this, What are your feelings on it? I'm not as concerned for myself about it as much as I am other observers at higher latitudes. Oh, thank you, Flying Tiger. Yeah, so, let's see, we've got 6 images so far. I might go ahead and do... Yeah, see, there's an issue here. I was thinking about maybe doing a quick stack of the images we got so far of this. The only thing is, time is precious here. This galaxy is in the west and setting lower and lower with every minute. And I really do like how on point the tracking is right now. The adaptive optics, all that, it's just going gangbusters right now. So I don't want to mess with it. If it's not broke, don't fix it, right? So it's at 54 degrees. It was over 60 degrees when I started, I'm pretty sure. Yeah, when I started out the webcast, it was over 60 degrees. It's now down to 54.6 degrees and dropping, which is still decent, but don't really want to waste precious minutes on it here. The thing about this camera, it's old. The software for the camera, also old, also not supported anymore. I'm using CCD soft, which was never designed to be used with Windows 10. This software long predates Windows 10, or Windows Vista, or Windows 7, or any recent incarnation of Windows. and it does not like the new versions of Windows. The camera experiences a major problem with the new versions of Windows when you open up any other windows, which is just ridiculous. I know. I still don't understand why that is, why that happens, but I know it does happen. And what ends up happening is if I open up another window to do anything, like stack the images, it will fill the image currently being taken with light, as if you had shone a flashlight down the telescope tube, sort of, but in this Venetian blind sort of way, where you get these sharp cutoffs from the area that got affected and the area that didn't, or didn't get affected as much. It's some weird anomaly, and it can happen even with the shutter completely closed. It's like some weird interference that comes from opening up another window, and it feeds into the camera somehow, or into the readout of the camera, and in any case, the final resulting image is ruined permanently. So I dare not touch Windows in terms of opening up any other windows. Even if you've already got another window open, if you just tab over to it, it'll ruin the picture. And when I first discovered this, or when I first started noticing it under Windows 10, with this laptop I've got, this is a relatively new laptop for me. The old one, I used to have, actually I had a series of old laptops that were still running Windows XP, and the software seemed to work just fine under Windows XP, never had a problem. But under Windows 10 with this new laptop, oh, it's awful. It makes me want to go scrounge around pawn shops just to find a copy of Windows XP. I don't have a copy of Windows XP anymore, silly me. I should have kept one of those keys so I could run Windows XP on this machine. I don't know. I don't know if Windows XP would work with the new processors and all that stuff. I don't know. Windows XP could be finicky, I know, sometimes. But, man, I kind of wish I still had one of those old machines, even though it had the limitation, you know, those old machines didn't have the processing power needed to run OBS Studio and webcast like this. So for some reason, Google Hangouts usually is lighter weight and seems to work better for those old machines, but even they had trouble with Google Hangouts sometimes, so that was a bit of an issue. It's why I thought it was a good idea to upgrade to Windows 10. But as it turns out, this software doesn't play nice with Windows 10, neither does the camera. So I can't really do stacking as I go with it like this. This is one of the reasons, another one of the reasons, I want to set up my own website for all of this stuff. In fact, I've already got the URL booked, astronomylive.space, and there's nothing there now. If you go there, it's just a blank placeholder. But that's where I'm going to be doing some of this additional stuff, things like showing where the telescope's currently pointed, things like doing some more dynamic processing of these images and serving them up live. And the idea there is I can run that off of a Python program that's running quietly in the background, that I don't have to tab over to it, I don't have to do anything while the images are being taken. It can just handle it for me automatically if I write it to do that. That's the plan. But that's the bugger of it. I can't open up Deep Sky Stacker, I can't do any kind of processing by hand while this thing's running. It's okay if I have something else like a Python program running in the background, but in terms of like opening up other windows and manipulating them, that's a big no-no. That's why I've got the chat on my phone, actually. I don't open up the chat window on this computer anymore, because that was one of the big problems. That's what was causing a lot of the images to get ruined. And at first I thought it was a problem with the camera itself. I thought the camera was dying. So I went out and I bought an identical camera to replace it. Turns out, started having the same problem again. I'm like, okay, I've changed everything about the camera. Why is it still doing this? And it turned out, well, the answer wasn't anything to do with the cameras per se. It was really Windows being not nice. So I've got an extra camera. I might end up using that in future webcasts. I don't know. We'll see how it goes. NGC 3628, also known as Hamburger Galaxy or Cirrus Galaxy, unbarred spiral galaxy about 35 million light years away, constellation Leo, Discovered by William Herschel in 1784. Thanks, Bill. It does look like a hamburger, doesn't it? Tasty. So, yeah, you know, sort of having my own site, having my own program running in the background, handling these images, it'll all help. Twofold. It'll mean that you guys get to see better quality images. It'll also mean I don't have to open up any other windows that would interfere with the camera. Like I said, I also have a second, now identical and redundant camera, but I am thinking about mounting that on the wide field refractor that normally rides piggyback on the telescope. In fact, I've got it on there right now. I've got the telescope, this 80mm wide field refractor, riding piggyback on my main telescope, but it's not doing anything. It's just sitting there useless. So it'd be cool to have the second camera up on that and have both cameras going at the same time. I might have to feed the second camera into a second computer. I'm not sure. It's a thought. It's a thought. One of the reasons for doing that would be if somebody's requesting to view an object that's way too big for this telescope to see, because it would more than fill the field of view. Sure, I could point it at that and show them just a piece of that object, but yeah, that's probably not what they're really asking for. It'd be nice to be able to switch over to a wider angle view, but with the same camera, same type of camera anyway. And I could do that just easily on the fly if I had the second camera up on that wide field refractor. To do that, I would have to definitely add some more counterweight. These cameras are heavy, and I don't want to add any more weight to it until I've got it ready to offset with proper counterbalance. Always make sure you got your telescope balanced when you're using it, otherwise you're going to wear out the gears and it's just not good. You're not going to have good tracking or anything else. So you want to make sure your telescope's well balanced. So like I said, I would have to add more weight to the front end to balance out additional weight at the back. I could maybe do that, but the box I've got right now that holds the counterweights is kind of full. I can add a little bit more, but I don't think I can necessarily add enough to be able to counterbalance a whole nother camera. So I might have to, I don't know, add a second counterbalance box or something, work out some other deal with it, or add a bigger counterweight box. It's a homebrew solution for sure. If you saw this thing, it's an electrical junction box filled with fishing weight, but hey, it works. And it's a lot cheaper than the commercial alternative. So I can add more fishing weights into the electrical junction box to serve as a counterbalance. But like I said, it's only got so much space. It can only hold so many more weights before it's full up. So may have to go to another solution. Or just add a bigger box. Oh, thanks, Kind Wolf. Thanks for stopping by. Run dual scopes of different focal lengths. Yeah, that's exactly what I'm talking about doing, Scott. Is have a second wide field refractor to provide wide angle images. And to be clear, this is not, all of this is not to try to compete with services like SLU or iTelescope, where you're working with really high-end telescope equipment, observing throughout the night, every clear night. I can't compete at that level, and that's not what I'm trying to do here. This is just about trying to make what I'm doing right now more interactive. And think of it as an interactive star party, especially for people who don't have access to such nice equipment. I'm sure a lot of the people watching right now don't have a nice telescope like this. They probably don't have a Losman D or an LX200 or anything else. And they want to be able to see the night sky, and see some of these small, faint galaxies up close. So that's why I think it'd be cool to be able to provide that, but do it in a more informal way, perhaps, than SLU, or especially iTelescope. iTelescope is fantastic. You know, if you want high quality, high-end observations with the best equipment that money can buy, a telescope is the way to go, and I could never try to compete with them. In fact, I'm a scientific advisor for them. They're a great service, so if you want to schedule an observation, you just want the images, you want the data, the raw data, you can get it from my telescope. SLU is nice too, and it's definitely less formal than I telescope in the way it's set up. It's more community-based, I would say. At least years ago when I used it, it was definitely more of a community experience where it's a shared, normally most of their shows are like a shared observing experience with other people, kind of like what we're doing here. But I feel like I could offer just sort of a more personal interaction, and still more informal and hopefully less intimidating than SLU. The idea being that, you know, we're a community here on YouTube doing this, not as frequently perhaps as what SLU does, but the idea is you have a more direct connection to the telescope, more direct control perhaps, and, you know, we're our own community here on YouTube, for better or worse. And you guys know how it goes. There's usually every week there's a new controversy or claim being made by various communities here on YouTube related to astronomy, whether it's flat Earth, Nibiru, or whatever. And so I think it'd be cool to be able to offer this so that people here on YouTube, if they have any questions, if they have anything they think is being hidden by the powers that be, they can dial into this amateur's telescope and take a look and see for themselves. Yeah, John Michelson, he's got some good images. I've seen some of his, and I know Geistview's got some new equipment too. He's got some fantastic images. He's already collected a whole collection of images I'm jealous of. So again, I'm not claiming that my equipment is the best out there. Even within the YouTube community, there's amateurs with better, newer, nicer equipment than what I've got. But I'm sure there's lots of people watching who don't have any of that and would love to be able to, you know, control a telescope like this and pick out what object to view and that kind of thing. So that's what I'm hoping to be able to offer in the future. And, you know, obviously I don't have the time, weather, or ability to do it every single night, but I would be aiming for at least once a month, especially around new moon weekends or time of new moon. Actually, today is the new moon, so no moon in the sky, nice clear dark night. That's what you want for this kind of deep sky observing. Yep, guys, view at the South Pole. Oh, jeez. I was trying to open up the chat. I accidentally thumbed down my own video. That was good. I didn't even know you could do that. Yeah, the South Pole presents its own problems for flat earthers, doesn't it? The midnight sun, the way the sun moves in the sky from the South Pole, the way the stars move in the sky from the South Pole. The South Celestial Pole shouldn't exist on a flat Earth. And I've seen the South Celestial Pole. I know it exists. It's not just Geistview lying to us all. So let's see what else is up there for us to look at. I'm assuming by the time we're done imaging this particular galaxy, the other two in that Leo triplet that are right next to it are going to be too low to really be worth going after. Maybe, but I'm going to take a look here real quick. See what else is on the horizon, so to speak. But not actually on the horizon. High up in the sky is better. What might be good to look at? Ooh, the Black Eye Galaxy. That would be cool. Now there's an example where I'm definitely not going to be able to get the kind of high quality guide star I've got right now, pretty much have to settle for something else. Something dimmer. I could do it. Definitely could do it. Just want to see if there's any low-hanging fruit in that area, though. Yeah, the whole area around Coma Berenices is filled with tons of beautiful small galaxies to view, and they are well positioned at the moment. They're actually about in the same location in the sky where this galaxy was when we started. So now would be a good time to move over to some of those guys and take a look at them. Like I said, I'm just trying to see where is the lowest hanging fruit in terms of getting a really good guide star. Ooh, Coma Pinwheel Galaxy. I like the sound of that. I don't think that's one I've really looked at before. I've looked at Black Eye Galaxy before. We've looked at that on some of my old streams back in the day. But the Coma Pinwheel Galaxy is not one that I think I've looked at in the past. And there is a nicely situated guide star that I can get. Magnitude 6.5, that's fantastic. Okay. Where's it at? Okay, it's at 63 degrees, 246. Alright, we're going to go ahead and stop on the Hamburger Galaxy here. Stop taking pictures of that. We'll come back to processing the images at the end of the webcast, but I'm going to move straight on to the Coma Pinwheel Galaxy, because that just sounds cool. It's Messier 99, NGC 4254. It's got multiple names. And its magnitude 9.82, 42 million light years away. We're going even further away now, in the constellation Coma Berenices. So, I should just be able to dial that up in the telescope real easy like Messier 99. Let's go. I'm going to go ahead and say, okay, we're not going to auto-save for the moment. This M99. Set it back to image 0. And we're going to go down to 1 second, 3x3 binning. Light, auto dark. Okay, so I'm going to go ahead and move the telescope now and reposition the camera. Alright, I completely rotated the camera because I would have needed to get the guide star that I want. I'm not sure how my angle is. I may have to reposition it. Okay, we've got a bright star. Let's see what we're looking at here. I kind of wonder if that bright star is actually the one I want to be the guide star. It could be. Let's go to 9x9 binning. Do 10 seconds exposure. Just want to see where I'm at on things. That might be a little too ridiculous. I don't know. Ah, no, that's got it. Yep. So I was correct. You can see the galaxy. It's really low resolution here. I sacrificed resolution for sensitivity for initial positioning here. But, okay, stop taking pictures. you can actually see down here, this is actually the spiral galaxy that we're going to be taking a picture of, and this is going to be the guide star. So I just need to move the galaxy up and the guide star up to get it where I want it in the field of view. Pretty cool. Okay, let's go back to 3x3 binning. I don't need to see the galaxy at this point, I just need to see the guide star and make sure we're moving the right direction. So let me see here. Based on the sky chart, I should actually move it north, or maybe south. I don't know. It's weird because the view's inverted, so I think I actually need to move it south because the view's gonna be inverted. Do I have that right? Let's see. Yeah. Okay, that didn't really quite do what I wanted. Let's try east. Oh, it's gonna be west. We'll get it right eventually. Okay. Yeah, it's gonna be west. And just so I can see. Let's center it up a little more so it definitely goes into the guide sensor, because the guide sensor is up above this field of view, but it's kind of smaller. It's a lot smaller, so I don't want to miss. So we're just going to send it up there. Okay. Now, we're going to stop taking images with that. We're going to start taking images with the auto guider. And watch for it to come in. Okay, I can't do that, and well, I guess I can do that and that at the same time. Let's just switch it. Okay. Okay, watch for it to come in. Hopefully it does. Hopefully I don't miss. Oh, there it comes. Beautiful. So now I'm going to have to recalibrate because I've completely rotated the camera. So if the telescope tried to steer based on how the camera was oriented last time, it would get it wrong. Okay, that's good there. Alright, so I'm going to do, sure, we'll do 1 second exposures. We'll calibrate the drive, y-axis for 8 seconds, x-axis for 5 seconds, go. No, stop. Sorry. I goofed that up. I told it to use the accidentally told it to use the main imager as the auto guider instead of the auto guider as the auto guider. Okay. Try that again. Calibrate. Okay. So now it's going to move this star back and forth like it did at the very beginning of the webcast, so it can relearn how to move itself to position the star where it wants it. In this case, I actually want the star's basically directly over the galaxy, more or less. I want the star to be at the bottom of the field of view when we're done calibrating. Alright, let's look at the calibration results. Make sure y-axis is symmetrical, like that. Okay, let's now reset and center the AO. adaptive optics unit. Let's calibrate the adaptive optics unit just to be safe. That shouldn't change because the adaptive optics unit is firmly attached to the camera. It rotates with the camera, so it really doesn't change how it moves the star. The axes are still the same. So that's a bit redundant, but just to be safe, I like to redo it just to make sure everything's okay. That looks fine. So now we're going to move this star down towards the bottom of the image to make sure the galaxy is as centered as possible, centered as it can be. I think I want it on the bottom left, really, to get it where I really, really want it. Sort of. Because as I recall, when we looked at it in the main imager, the galaxy was down and to the right of this bright star. So we want the star down and to the left in this image. Oh wait, it was down. It was down, but yeah, you also have to account for the gap. There's a gap between the main imager and the autoguider. And according to SkySafari, that gap is just about right, so that if you position this star at the bottom, the galaxy will be just above the center in the view. Okay, that's good there. So once again, we're going to start up the autoguider first. M99 is on. We'll say autosave, turn that on. Have it begin autoguiding. Oh, that looks really good there. The star's even brighter. It's not having any trouble at all, even at 20 Hertz, 22 Hertz. That's fantastic. Okay, so now we're going to take images with main imager. We're going to go to 1x1 binning for maximum resolution and color data. We're going to set the exposures to 5 minutes apiece. And we're going to start. Hey Sam, is there a way to make a program to remove the wayward pixels? Yeah, there is, and that's kind of what I'm going to do. That's my plan anyway, is to make a program that will not just subtract a single dark frame like what this is going to do, but will actually subtract a master dark frame that was compiled from a whole library of darks, where you've taken like 20 or 30 or 40 dark frames. And you can even do that during the day. You just have to set the camera to the right temperature, -5 degrees Celsius in this case. And you have the shutter closed, and you have it taking those dark frames, and you average them together to create a master dark frame. And you subtract that one from the images. So I can write a program that will do that, definitely. Scott Mayer says he'll have an ETX 80 soon. Well, good luck with that. Hope it serves you well. I had an ETX 70 for a while back in the day. Wasn't a big fan of it. It was okay. But, yeah, it wasn't great. The ETX 80 should be better, I think. I think the 80 has got a completely different auto start to it. And probably better gear system, drive system, hopefully. The ETX 70 always felt like it was on the verge of breaking. It didn't. It kept working, but it just always felt creaky and just not so hot on the go-to accuracy. It was just never as good as I would have liked. So that kind of soured my taste for the ETX telescopes a bit, maybe, and it probably shouldn't, because like I said, the 70 The ETX70 was a cheaper scope than some of the other ETXs, and they're not all the same. Oh, thank you, Flying Tiger. There's lots of other good astronomy channels out there, too. I'm not going to speak ill of any of them, really. Hey, Redhead. Was that addressed to me? Your buddy is the department head at Benedictine University, Atkinson, Kansas? Likes my setup and explanations of what I'm doing? Oh, wow. I'm honored. Thanks. What are we looking at tonight, Sean Hufford? We are looking at the Coma Pinwheel Galaxy, Messier 99, NGC 4254. And Coma Berenices, magnitude 9.82, 42 million light years away, 60 degrees above the horizon currently, and setting into the southwest. Oh no, you got work lights out there, huh, Sam? Oh boy, there's a dumpster fire debate, Cavalier. Let me guess, is it on non sequitur? I don't know. I didn't know there was going to be a debate tonight. I thought there was going to be a debate Friday, or was that last Friday? I don't know. I had to work this weekend, so my weekend sort of blurred together. I just feel like it's one long week. I don't even know what day it is today. It was on Fight the Flat Earth, and Nathan Thompson acted like a child. Oh, dear. Oh, dear. I heard there was a debate between Mick West and Nathan Thompson in Las Vegas, like a week or two ago. And according to what I heard on Mick West's podcast, it was filmed, but he said he couldn't find any... Ooh, that's a really nice spiral. He said he couldn't find it online, so I don't know if they're going to post the footage of that debate or not. I hope they do. I'd like to see it. Ooh, that is really pretty. That is real nice looking, isn't it? It's up in the top right of the image. I probably should think about moving the guide star more to the left, but... I think I'm just going to leave well enough alone and not fool with that. It was already kind of pretty far over to the left. I wouldn't gain much. I'd gain a few pixels, but I wouldn't gain much in terms of repositioning this galaxy at the present time. That is really cool looking. I like the look of this galaxy. You can really see some nice detail in terms of the dust lanes and the spiral structure. Even now, before the hot pixels have been taken out, before we even got the dark frame in. See some nice detail there. It's gonna make for a nice image. Ah, no, I want to zoom out. Zoom out. Okay. I wonder if I can... yeah. While it's taking the dark frame, I'm just going to reposition the guide window over to the right. Oh, no. I don't want to do that. again, I want to keep an eye on the guider window. There we go. Now I got the guider window on the right and the galaxy on the left. That works for me. So it's a nice face-on spiral. The last one was an edge-on spiral that we were looking at it kind of like how we look at our own Milky Way, into the edge of the plane of the galaxy. Now we're looking at it face-on. Oh, he's finishing up a spectroscope for their observatory for some donors. That's awesome. I'd love to get into spectroscopy with my scope. We Be Good says we need to ask Elon Musk to put a telescope on each Starlink communications to develop a long baseline optical telescope bigger than the Earth. Yeah, I don't think the technology's right there right now in terms of optical interferometry. That would be cool, but I don't think the technology could really support that. The precision that you have to have for positioning your telescopes, even at radio wavelengths, is quite high. It's manageable, but you have to know the relative positions of the telescopes quite well, and there's a whole bunch of other technical difficulties that go into it. It's doable with our current technology level, but in terms of visible light, optical interferometry, much more difficult due to the wavelength being shorter, and in terms of trying to precisely position it, I'd have to do the math to see what kind of precision you would need to achieve, but I'm sure it's insane. And I'm sorry, I don't even think SpaceX is up to the task of that. I don't think anyone's up to the task of that yet. Maybe someday in the future, but I just don't see it. Even with laser ranging between the satellites and everything, I don't know that they could get the accuracy they would absolutely need for that kind of interferometry. Not to mention the difficulty with combining the waveforms from the various telescopes on the various satellites. It's just, it gives me a headache thinking about the technical difficulties that would be involved with that. Sean says, just left of the little window, even with the delay modifier, there is a fuzzy object. The little window. Well, the little window is just the auto-guiding star. You say you see a fuzzy object on the left of the auto-guiding window? There might have been a few pixels before that were just standing out. The main window, there might have been another faint background galaxy or something. Tell you what, let me just zoom out. Yeah, there's faint something there. There's probably a satellite galaxy of this main galaxy or something. Let's see if I can find anything on my sky chart here. I don't know that I've got anything that dim listed. Magnitude limit. Let's go. Maximum limits. Yeah, there we go. Okay, that helps. Now I can see where other things in the field are supposed to be. So there are a couple of PGC objects up and to the left of the main galaxy. I can't tell which one it is. There's a couple that should be up here. PGC 169043 and PGC 169040. That's probably one of these guys, I'm guessing. So that may have been what you were seeing, I'm not sure. But yeah, now that with those hot pixels subtracted, you can see the galaxy much better. It's to the right of the spiral galaxy. The stacking window's covering it now. Oh, this guy here. Can move it wherever. Gotta move it on my end too. There's a little star there and there. There's a little fuzzy spot of the galaxy. I think that's just part of it there. It's just to the left of the top corner of the stacking window now. Top right corner or top... which top corner? I'm confused. I'm sorry. So, if it's the top left corner, then you're saying it's off the view, you can't see it right now? How could it be to the right? I'm trying to understand, like... that one. Which one? I'm confused. This guy right here? This star I'm pointing out with the cursor? Stream delay sucks. Okay. Yeah. I mean, what I'm pointing out with the cursor right now is just a star. Up here there's a faint thing that's probably a PGC galaxy or something. There's another one or two up here. It's not CGI. I'll screen cap and Skype. Okay. Yeah, it's the stream delay makes it impossible. And it'll be easier when this is all done anyway. Then I can throw it into astrometry.net. I can't do that right now because I can't pop open any new windows while this is running. But when it's all said and done, I can throw it in astrometry.net for you and find out the exact coordinates, and then we can figure out exactly what it is. It's dust. It could be dust. I don't know. Okay, I just got the Skype message. Ah, okay. Yeah, that is just a star. That's just a background star. I don't even have an ID for that at the moment, but I guarantee that's just a star. It's a little distorted by some coma. This is a Schmidt-Cassegrain. It's not one of those cool Edge HD optics like they've got now, and it's not a what do they call it? Meade got sued for it. They called it Advanced Refrigeration. They call it RCX or something. They got sued for that name. But whatever. Advanced Coma Free, I think is what they call them now. ACF scopes. This is not an ACF scope. It's not anything like that. So it does have some coma towards the edge of the field of view, which makes the stars kind of have this triangular shape to them a bit. But Yeah, whatever. It's good enough for me. I'm happy with my little scope. I don't get as picky about that as most astrophotographers do. Hey Redhead, we are looking at a face-on spiral galaxy right now. M99, Messier 99, also known as the Coma Pinwheel Galaxy. The top right window is just a guide star being tracked by the adaptive optics unit, and it's correcting the image at over 20 times a second. Currently it's running at 23 Hertz, so it's correcting for both mount tracking errors as well as atmospheric issues. Fine job of it. I tell you what, that adaptive optics unit, although a lot of people, I think they go for so cheap on the market in part because a lot of people didn't use them even when they bought them, because they're a bit of a pain to set up. They have to be physically bolted into the camera, and it's a whole process to assemble the thing. But it is totally worth it in my opinion, because it really makes the scope punch above its weight. You know, the way you get these nice round stars that are really tight, really well tracked, you normally wouldn't get that just with regular auto guiding. Even with auto guiding with a scope, the motors can't respond fast enough to compensate for the tracking errors. This is not a Losman D, this is not a astrophysics mount, this isn't you know, a super high-end mount. It's good, but it's not great by today's standards. And as a result, your stars are going to be bloated by the fact that when you auto-guide, it's correcting for the errors it sees the mount make. But by the time it's corrected it, it's already happened, especially when you consider the backlash. The motor has a certain amount of backlash. It takes a few seconds to reverse direction, to take out the slack in the motor. That's how it's designed. And so, by the time the correction has had a chance to kick in, it's already too late. Your image is already ruined. Well, maybe not ruined, but it's less than ideal at that point. This thing, because it's an adaptive optics unit, it's using this tilt-tip mirror system that can very quickly turn a mirror. Everything you're seeing in this image is being reflected off of that mirror, and it can keep the image perfectly stable. It's like image stabilization at a very high rate for a telescope. 20 times a second it's reading the position of the star, and it's keeping it perfectly centered. And at this rate it's correcting not only for the mount faster than the mount could respond, it's also correcting for some of the atmospheric turbulence as well. Sean, do I plan on putting on a solar filter and finding uncharted stars? Yeah, I would find uncharted stars. The only thing I would find at that point is uncharted stars, also known as just whatever's left of the hot pixels. Along with the Planet X system. And Gil Broussard's Planet 7X. I searched for his Planet 7X years ago. I did a series of videos about that over multiple nights, charting a huge section of the sky in infrared, actually, just to make sure there were no excuses. I reverse engineered the orbital elements of his Planet 7X based on the charts they showed, figured out where it would be, and keep in mind, his original doom date for that has already come and gone. It's already come and gone. Now, he projected it could arrive as late as like 2021. So I searched over huge regions in the sky saying, okay, even if it were arriving late, it would be back here. And according to his chart, it showed it reaching like naked high magnitude by the time I was looking for it. It would have been bloody obvious to the telescope. Because remember, this star right here, this is what a naked eye magnitude star looks like to this telescope. and that's at 0.02 seconds exposure. Okay, at like 5 minutes exposure, this thing is completely washed out, overblown. You know, didn't find anything. Didn't find a single thing out there that would be consistent with his Planet 7X. Basically, I looked for things that were moving over, I don't know, a few weeks of time. Didn't find any planet. Just the usual stars and galaxies and whatnot. So, yeah. Pretty much ruled out his planet years ago. So, if you search on my channel, what did I call those videos? Broussard. I'm pretty sure I had Broussard in the title. If you search for his name, you'll find it. Let's see, what are we on now? Image 4. Okay, serious question. Stars you got with that scope, are they literally still point sources, or can you get an idea of the angular size from them? They're still point sources, even at this magnification and resolution. Yeah, there's no way I can resolve them. You need interferometry to be able to resolve the actual angular sizes. And basically that means you need radio telescopes with our current technology. You know, they're, I don't know, micro, sub arc seconds of size, angular size. The angular scale of the images you're looking at right now, I'd have to look at it again. I want to say it's around 0.7 arc seconds per pixel, somewhere in that ballpark that you're looking at, which is still, you know, it's a tiny angle. 1 arc second, for those who don't know, is 1/3600th of a degree, and that is bigger than the individual pixels that you're seeing in this image. So you're looking at, you know, a tiny galaxy, really, in a tiny portion of the sky. Let's see, according to Sky Safari, the galaxy, for example, has an angular size of 5 by 4.7 arc minutes. And the full moon and the sun occupy roughly 30 arc minutes in the sky. So, just to give you some sense of scale, this galaxy here, and we're talking from the very faintest reaches to the opposite side, is about 6 times smaller than the sun or moon. So you're looking at a very tiny object in obviously a very tiny part of the sky. But even at that scale, no, you can't resolve the stars. Yeah, Betelgeuse. I think Betelgeuse is large enough, I want to say, that I think Hubble and maybe some big scopes with adaptive optics, real professional adaptive optics, can start to resolve it. Definitely not with my scope, though. Very large array. Yep. Yeah, Kits Cavalier, you got the rich because I accidentally booted you the other night and I didn't want to do that again. You gotta be careful with the phone. The magnitude of the galaxy is what? Had that a second ago. 9.82. So, yeah, dimmer than naked eye magnitude. Considerably so. And the distance is 42 million light years. We are looking at Galaxy Messier 99. Yeah, I was saying it's about 1/6 the... Not 1/6 the area, but in terms of the width, it's about 1/6 the width of the Sun. Because it's about 5 arc minutes on a side. The Sun and Moon are about 30 arc minutes wide. This is Galaxy Messier 99, also known as NGC 4254, also known as the Coma Pinwheel Galaxy. Face-on spiral galaxy. So I do think this is going to be the last object I do tonight. I think the clouds are supposed to move in after midnight. I can see some flashes in the distance. Probably storms offshore. I don't think they'll come this way, but it is a little concerning when you see that sort of thing. Just gonna get up for a second and check the weather one more time, make sure I'm not about to get overrun by something. Nope. Looks clear at the moment. Ah, that's a good question, Sean. Other than Andromeda, what are some naked eye bright galaxies? Well, that's a tough one. So, I'm trying to remember what the brightness of Triangulum is. Let's see. Yeah, that's what I thought. M33, the Pinwheel Galaxy. Well, this is the Coma Pinwheel Galaxy. The original Pinwheel, I guess. I don't know if it's original, but the one I always think of as being the Pinwheel Galaxy, also known as the Triangulum Galaxy, also known as Messier 33, is technically naked eye magnitude at 5.8 visual magnitude. However, I have personally never spotted it by naked eye. I've spotted it in binoculars easy enough, but extremely difficult. I don't know if it's really doable, all that doable. In theory it is. It's huge in angular size, and so the visual surface brightness is quite low. So I don't know if the surface brightness is technically enough to see it by naked eye. Its angular size, according to Sky Safari Pro, is 61.7 by 36.3 arc minutes. So it's actually larger than the sun or moon in the sky. It's a pretty big beast. Like, right now, this whole field of view, it wouldn't fit in this field of view at all. Not even close. Even the autoguider window, which is, as I said, there's a gap between the autoguider window and the main window. You could fit both in that galaxy comfortably. So, It's a whole huge galaxy. I don't know that the naked eye is actually sensitive enough to see it, because although it's technically magnitude 5.8, that brightness is spread out over a degree of sky, or, you know, degree in one direction, half degree in the other, whatever that is, you know, an oval shape in the sky that is actually larger than the sun or moon. Andromeda Galaxy, for reference, is visual magnitude 3.36, which sounds really bright, really, when you think about it, and you think about how bright stars are, but it's also spread out over an even bigger region of the sky, 177.8 by 69.2 arc minutes. So, there again, yeah, it's technically bright enough, technically easily bright enough, but it's not so easy. It is doable, but it's not easy by naked eye, because it's spread out over such a large area. So yeah, there's a couple galaxies there that theoretically are bright enough, but really only one is easy to do. Let's see what else we got. I don't know. Just curious, I'm just looking around. There's a globular cluster over there. A couple of globulars over there. Yeah. Yeah, Andromeda is a credible sight to see by naked eye. Yeah, like I say, really, when you see it by naked eye, it's a good point, Scott. You're really seeing just the core of the Andromeda Galaxy. Even when you're looking in a telescope, oftentimes what you're really looking at is the core. The whole galaxy is huge and fills more of the sky than the sun or the moon. But we can't see that much by eye. Sculptor Galaxy is an easy binocular galaxy. Yeah, that's a good example of an easy binocular target. I actually can't say I've actually seen it in binoculars, but I imagine it would be, just because I have seen it in the telescope and it's quite easy to see. Visual magnitude 7, so it's right there at the limit of human vision, but again, because it's not a point light source, it's an extended object, that light is spread out over a wide area. It is 26.9 by 4.62 arc minutes, and in the current field of view, I don't think it would quite fit. With my focal reducer on, it does fit very nicely in the field of view. Sculptor is a great target for this telescope to see. Oh, they updated. Very cool. They updated my Sky Safari Pro to show the Starlink satellites. I see a train of them going overhead right now through Sculptor. Well, I don't know if Sculptor is really above my horizon at the moment, but I'm just looking at the sky chart. They're going, if I could see them, they'd be going through Sculptor right now. have any optics that could get Andromeda as a whole. I think so. I think my wide field refractor could do the job. I've done it before. Never really put a serious effort into getting the best possible image of it. My wide field refractor is not the highest quality thing. It's good enough for most people. Most people wouldn't know the difference, but if you're into serious astrophotography, you're going to notice the chromatic aberration right away. So I've never really dedicated a huge amount of time to trying to get it. But I think maybe my 80mm refractor could just fit it. Let me see if I've got a field of view for that. It doesn't look like I ever configured a field of view for that, which is surprising. I'm gonna configure an approximate telescope. That's an approximate. That's an approximate approximation of what my 80mm refractor is. It doesn't quite fit, but I think in practice it basically does, just barely. I just plugged in rough numbers for the focal length and focal length and aperture of that telescope, and said, okay, how much field of view would my camera have? I've already got the numbers in there on my CCD pretty precisely. It says the edges of the galaxy don't quite fit, but you could always do a panorama. You could get it in 2 frames easy, very easy. You just take one shot, you take the other, you stitch them together, done. Oh, it's a composite. It's all CGI. It's all fake. The funny thing is, I mean, when you're talking about single-shot color images like this, or any digital color image really, they're always combinations of data from different sets of pixels. You've got red, green, and blue pixels in a matrix, and the final image is being interpolated from those pixels. So, and any consumer-grade digital camera is going to do that automatically, invisibly, behind the scenes. You don't see it happen, but it's happening inside the camera. It's taking that matrix of pixels, it's debayering it, it's interpolating what the final pixels should be. So, with your cell phone or your digital camera, when you take a picture, if you're saying that any image manipulation, any processing, any composition of multiple layers of image data makes it fake, then every picture you've ever taken with a digital camera is fake. The only real images by that standard would be grayscale images from grayscale CCDs that you haven't touched at all, in which case it's just raw pixel values. Generally speaking, the digitizer for most CCDs like that are going to be 16-bit. You won't even be able to natively display them on your typical monitor. This monitor, for example, 8-bit monitor, these images are being taken by a camera that's digitizing them in a 16-bit format. These are 16-bit images. and we're only looking at a portion of the histogram. So that's how CCDs work. But of course, some are going to say, well, you're processing these images, you're subtracting dark frames, you're compositing the final image. It's all fake, it's all CGI. It's real image data. It's just being processed in a way that we can actually see, in a way that the monitor can actually display. Alright, Sean, have a good night. Isn't Lucifer a Jesuit observatory? No, it's not. So there's a interesting little story. And I always relate it to an anecdote I'll explain in a minute. But Lucifer, for those who don't know, is an acronym for a CCD camera, an infrared camera, that was built for the Large Binocular Telescope on Mount Graham. Now, also located on Mount Graham is the VAT telescope, VATT, which is owned by the Vatican Telescope. It's the Vatican Advanced Technology Telescope, I believe is what the acronym stands for. It's not Lucifer, it's not Satan, it's VAT. That's the name of their Vatican observatory. Some ask, why does the Vatican have an observatory in the first place? It's a great question, and it's an interesting answer. And my understanding is that the history of that relates back to the formation of the Gregorian calendar that we all now use. Basically, over time, the Catholic Church noticed that the timing of the seasons was not lining up with the dates for Easter. Precession was causing things to change, and the length of the year wasn't quite right on the calendar. The Julian calendar puts the year at 365.25 days. You have a leap year every 4 years. Most people think that's how our calendar works now, that we have a leap year every 4 years. That's not quite true. It's true that there's this fraction of a day that isn't accounted for in a 365-day calendar. And it's close to a quarter of a day, so if you have a leap year every 4 years, to add an extra day, you'll cancel that out roughly and have a calendar that lines up reasonably well with how long it takes Earth to go around the sun once. But that's not entirely accurate. It's a little bit off from that. And so this started to build up over time, very slowly, but after, some 1,000-something years, it had built up enough that the Catholic Church noticed it and it was a problem. So they commissioned the development of a new calendar to compensate for this, and came up with the Gregorian calendar, which has slightly modified rules for when a leap year occurs. It's not quite every 4 years. It's close to that, but not quite. And it ends up with a year that is, if I remember right, 365.2425 days long, something like that. And I want to say the actual length of the year right now is 365.242191. I have that number stuck in my head for some reason. So, it's not quite 365.25 days. And that's why we have the Gregorian calendar. And that's why we have the Vatican Observatory, really. It all kind of dates back to that. Which required observing the sun, observing how the Earth is moving around the sun, and determining what the true length of the year is in order to come up with a better, more accurate calendar. So, some say that the Vatican's telescope is named Lucifer, and it's not. It's actually named the Vatican Advanced Telescope, Vatican Advanced Technology Telescope on Mount Graham. But also next door on the same mountain is the Large Binocular Telescope, which is a secular observatory. It's not owned by the Vatican. And they commissioned a new infrared camera for their big binocular telescope and called it Lucifer. And so the story got out that, and somehow it got twisted to say that the Vatican had named their telescope Lucifer. Well, first of all, it wasn't a telescope, and second of all, they didn't name it. Third of all, it wasn't theirs. And I relate it to an analogy like this. It's like, and they are on the same mountain, so they're located right next door to each other. They pay into the same, I think it's the MGIO, Mount Graham, something observatories, whatever. It's basically, it's the equivalent of paying into a homeowners association for telescopes. They have a organization that manages the logistics of those observatories on that mountain, and they all pay into that same group. But that doesn't mean that the Vatican owns the Large Binocular Telescope or the Lucifer camera. And I relate it like this. Imagine this were at an amateur level, okay, and you live in Chiefland, Florida. Chiefland, Florida has the Chiefland Astronomy Village. This is a place that you can live with other amateur astronomers that have very tight rules on things like lighting and all these other things to try to have the best possible observing opportunity. It's in a really dark, remote location in Florida, about an hour away from Gainesville. I go up there quite frequently when they have their annual star parties. And they all get together and own land in this neighborhood and have these really tight rules in place. You can't drive up there after dark with your headlights on. You're not supposed to do that. If you do, you'll get banned for life. So, imagine you live at Chiefland Observatory and you're Catholic. So, you're Catholic Chris, you live in Chiefland Observatory, you have your happy little telescope, you observe from there under their dark skies. But your next door neighbor is, we'll call him Atheist Adam, okay? Atheist Adam has a telescope, and he buys a new camera for his telescope. And he decides he's gonna, have a laugh at your expense and name his new camera Lucifer. And it's an acronym for something to do with astronomy, whatever. He calls this camera Lucifer. He says to his buddies, "Hey guys, I'm getting a new camera. This thing, I'm calling it Lucifer." And that should keep Catholic Chris next door away from it. He's not going to want to use this. I just named it Lucifer. Ha ha ha. But the story gets out that there's a new camera in town, and it's called Lucifer. And rumor goes that Catholic Chris has named his telescope Lucifer. And word spreads outside of town. Truth of the matter is, poor Catholic Chris didn't name his telescope Lucifer. He doesn't have anything like that. No, that's his next door neighbor, Atheist Adam. But what do you think Atheist Adam thinks of all of this? They're probably laughing all the way to the bank. Their little joke paid off even better than they could have anticipated, because now Catholic Chris is taking the blame for naming his telescope Lucifer. So, no, bottom line is, the Vatican does not have a telescope named Lucifer. The Large Binocular Telescope, which is a secular observatory, has a telescope named Lucifer. A camera for their telescope named Lucifer, which is an acronym. It's for an infrared telescope, and I think they've even changed the name at this point. But when it was commissioned, when it was built and installed, it was originally named Lucifer. So, there you go. And I'm sure the Catholics working at the Vatican Observatory were quite annoyed that the misinformation keeps spreading that they have a telescope named Lucifer. Yeah, Lucifer is owned by U of A. I'm guessing that's University of Arizona. That sounds about right. Yeah, Lucifer is an acronym for the attachment they added onto the telescope. I call it a camera, but it's basically an infrared device they attach to the telescope. Ah, Scott Mayer's pulled up the name. I guess that's... Is that where they got the name? I guess so. Okay, let's see if we figure this out. Large Binocular Telescope. Near-infrared utility with camera and integral field unit for extragalactic research. It's a really tortured name, isn't it? I guess, okay, you take the L from the LBT. Near-infrared, you ignored that for some reason. Say U for utility with camera, C for camera, I for integral, F for field. ignore the U in unit. For extragalactic E, research R. Okay, yeah, that's an extremely tortured acronym, isn't it? It's a very loose acronym, yeah. Somebody really wanted to call their camera Lucifer. Tortured acronym fits in this situation, I think. Yep. And just for completeness here, let's pull up the rules on the Gregorian calendar leap year to see the difference between just doing it every 4 years. So according to timeanddate.com, leap year added on February 29th, of course, almost every 4 years. So in the Gregorian calendar, 3 criteria must be taken into account to identify leap years. First is that the year can be evenly divided by 4, which is of course why it's almost every 4 years. The second criteria is that the year can be evenly divided by 100. It is not a leap year. So if the year can be evenly divided by 100, it is not a leap year, unless the year is also evenly divisible by 400. Then it is a leap year. And so this means that in the Gregorian calendar, the years 2000 and 2400 are leap years, while 1800, 1900, 2100, 2200, 2300, 2500 are not leap years. So unfortunately, it sounds like in our lifetimes, at least in my lifetime, we won't run into a year where we have one of these weird, due to Gregorian calendar rules, that it should be a leap year, but it's not, because rules. But if you were alive in the year 1900, it was not a leap year for that reason. Special leap year 2000. The year 2000 was somewhat special as it was the first instance in which the third criterion was used in most parts of the world since the transition from the Julian to Gregorian calendar. And that was the rule that if it's also evenly divisible by 400, then it is a leap year. So that's cool. So yeah, when was the Gregorian calendar first introduced? I want to say it was... It doesn't say on this article. So the Gregorian reform was introduced by Pope Gregory XIII in October of 1582. So some interesting history there. I guess it is kind of cool then that we did live through a year that, due to the third rule of Gregorian calendar being invoked, we did still have a leap year when in other turn of the century situations you wouldn't have. Didn't 3 weeks disappear at the switch? Yeah, there was a leap in time as a result of the switch between the calendars to basically reset things, to fix what had been unfixed for a while with the Julian calendar. And let's see. To deal with the 10 days... Okay, so when the calendar was introduced to correct for, according to Wikipedia, to correct for the shortening of the year by 0.0075 days to stop the drift of the calendar with respect to the equinoxes, the basically precession. To deal with the 10 days difference between calendar and reality that this drift had already reached, the date was advanced so that October 4th, 1582 was followed by October 15th, 1582. There was no discontinuity in the cycle of weekdays or of the Anno Domini calendar era. It also the reform also altered the lunar cycle used by the church to calculate the date for Easter, which was what basically kicked a lot of this stuff off, and the reason why they went to all this trouble of reforming the calendar. Oh, that's interesting. So, over the next 3 centuries, Protestant and Eastern Orthodox countries also moved to what they called the improved calendar, with Greece being the last European country to adopt the calendar in 1923. I'm shocked it was that late in the game, but I want to say that in American history, the U.S. adopted it sort of late in the game, I guess, and I want to say that caused some issues. If you look at historical documents of like George Washington's birthday, it can look like 2 different dates because of how it was recorded versus the calendar we use now. I want to say that's the case. Let me look that up real quick so I don't get that wrong. But Gregorian calendar, U.S. history, adoption in the U.S. Yeah, enactment of the Calendar New Style Act of 1750. Great Britain and its colonies, including the United States, adopted the Gregorian calendar in 1752. So it was before we split off, but nevertheless, it did. If you look at old enough documents, it is going to potentially lead to some apparent discrepancies. So yeah, for example, George Washington was born in 1732. So that was before they had adopted the new style of calendar, which is why there, depending on what you look at in historic documents, there's some apparent discrepancies in George Washington's birthday. Little fun history fact. Yeah, Greece has been traditionally Orthodox. They celebrate Easter and I think Christmas on different dates. Yeah, and that's why there's that whole split between the Orthodox Church and Catholic Church and all that. I don't know a whole lot of the details there on the church level as well as I should, but I do know that adoption of the calendar at various points in time from different countries leads to apparent discrepancies if you look at some of their historic documents. And because those calendars have different rules for leap years, of course, the discrepancy between them only gets bigger the longer into the future you go. Be interesting to see at what point in our future we would have to reform the Gregorian calendar again to keep up with the changing position of the seasons relative to our calendar. Because even the Gregorian calendar is not a perfect solution. It's much better than Julian, but it's still not quite perfect. Like I say, I think I want to say that the length of the tropical year is like 365.242191, and that number sticks in my head. Yeah, if I search for it here. According to timeanddate.com, a tropical year, also known as a solar year, an astronomical year, blah blah blah, is on average 365 days, 5 hours, 48 minutes, and 45 seconds long, which is 365.24219. So that's not quite the same as a Gregorian calendar. As you can see, there's still a little bit of discrepancy there. And actually, the length of the tropical year isn't perfectly fixed due to perturbations of Earth's orbit by the planets. So, over millennia, the Gregorian calendar will drift as well, just at a much slower rate than the Julian calendar. Alright, so we got about 6 minutes till midnight here, which is a good stopping point, also because one more image, 5 minutes long, will put us at 12 images collected, or 1 hour of light precisely on this galaxy. So that's a nice round number all the way around. Well, it's almost like I planned that, but I really didn't. So we'll stop it there after this final image. And as I start to tear down, I'll throw the images in the hopper to stack them. I did collect some flat frames before starting the webcast tonight. I'm not sure how well the flat frame subtraction's really going to work, since I didn't have the telescope focused yet. It was just whatever the focus had been left at. And so it's probably not going to work so well. Although you wouldn't think focus should affect flat fields, it does, because it alters how the light is basically passing through the optics and into the telescope and illuminating the dust motes, and it actually does shift it a bit. So, I don't know, in my experience, having it out of focus when you take the flat field's not a great idea. It doesn't work as well. But we'll give it a shot. Maybe it'll be good enough. Maybe it won't. If not, I'll come up with a alternative method, which in my case is usually pointed at the wall of my house with a light on it and take images. It's not the flattest field possible, but it works. You just want even illumination. Of course, the telescope's not going to be focused on the house, and you don't. You leave the focus exactly where it was when it was taking the images to get the best possible flat field. Damn dust motes, you're right about that. You also get a little bit of vignetting, even with... It surprises me, I mean, we've got a pretty open optical path with the adaptive optics unit. It threads directly onto the Schmidt-Cassegrain threads. There's no nose piece, it's just threaded directly on the SCT threads, and then it passes through the adaptive optics unit. But you do get some vignetting, and I kind of wonder if that is related to the mirror, the size of the mirror on the A07. I know they say you can't use the A07 on the ST4000 Axiom. I'm pretty sure you can't. Could be wrong, but I'm pretty sure you can't, or you're not supposed to. So the ST4000 has a bigger CCD. It's got 4,000. I think it's a 4, not 4,000 pixels. What am I saying? Well, whereas this is a 1600 by 1200 image, the ST4000 is like double the resolution. It's like twice the size of the CCD in the vertical direction, I think. So I think it's a 2400 by 1600 image, I want to say. I don't know. Something like that. It's like twice the size anyway. And I think that causes a problem because the A07 adaptive optics unit with its tilt-tip mirror wasn't designed for a CCD that large. So I'm wondering if that's really what's causing the vignetting at the corner here. But anyway, it doesn't matter. Flat field subtraction takes that out. Oh, thanks, Dan. Glad I could provide it. So yeah, we just got 2 minutes left here on this last image, and then I'm going to call it a night. Stack the two images, or the images of the two objects that we photographed tonight. We had the Hamburger Galaxy, and now the Coma Pinwheel Galaxy. Are you kidding me? Is that a thing that actually happened? I'm a yes. The Saudi Air Force sent up a spotter jet to spot the rising moon that denotes the end of Ramadan. Yeah, I know they look for the moon as the start and end of Ramadan, the first sighting of it. What's going on there? Surely that is cheating. I'm just surprised. Which adaptive optics do you use? I use the A07, the classic, the original A07. I'm rocking some old school gear here. The old ST2000, the old A07, and the old CCD software on an old LX200 Classic. Pretty soon this is going to be Smithsonian level telescope. I don't know. But hey, it still works. It's still kicking. Citation required. Yes, I'm a yes. Exactly. The 94 vintage C8. Ooh, the orange tube, right? Or was that the black tube era? I think that was still the orange tube era. Alright, that's the last exposure. I'm going to call it quits on that. Yep. Shut that off. Should I start warming up the camera? I'm going to wait on warming up the camera just yet. I just want to see and make sure first that the flat field subtraction looks okay. as light frames. That's not what I meant to do. To add them as flat frames. There we go. Okay. Now, let's do... Hamburger Galaxy was fun, but I'm going to do M99 here, the coma pinwheel first, because we got more images of it. Stack that first, just because it should be the highest quality. If I did things right. Stacking them now. 12 frames for the coma pinwheel here. Hopefully that's enough stars for it to register the images. Yep. Good. All the alignments are sub-pixel anyway. See how this looks. Okay. It looks good so far, but let me check it in PixInsight. Just in Deep Sky Stacker, though, it looks like it was successful, which I'm a little surprised about, but very happy if that's the case. Because I thought adjusting the focus might throw off the flat fields. I thought it had in the past, but maybe it was something else that was actually messing me up, and I just reached the wrong conclusion. Let's see, let's pull this image up, and then play with it a bit. Adjust the contrast and brightness, etc., etc. It does look pretty good in terms of the flatness of the field. That. Okay. Could stand to flatten the gradient. There is a gradient in the image, but I was definitely expecting that because I basically took images of the twilight through the telescope in order to get the flat field images, which is the poor man's way of doing it, but it works. But you do tend to get left with a gradient, and you can take that out with dynamic background subtraction in PixInsight. Subtract the background. Okay. Let's just apply some curves on this. Have some fun with the contrast. Come on. Just want to grab that point and move it. There we go. Yeah, it's not perfect. Some of the dust motes are still hanging around there a little bit, as I thought having the focus off did affect it, but you almost have to know where they are to see them, especially if you just zoom in on the galaxy. It's not really noticeable. So I'm going to save this quick and dirty processing of the galaxy and share the image. I could probably work to minimize the effect of the residual dust motes some more. But just as a quick and dirty processing, let me share the image. This is just with flat field calibration and stacking the 12 images. It's pretty nice, I think. It's quite reasonable. Fair bit of detail there in that galaxy. So as you can see, there's some residual hot pixels and stuff. I'll take that out with further processing later and upload a final stacked version and put the link in the video description. And while you guys are staring at that, I'm going to quickly stack and do the same thing to the other galaxy that we took a picture of. This is going to be the Hamburger Galaxy, which was that edge-on spiral we started off with, also known as NGC 3628. I'll be right back. Alright, so I'm just working on stacking the hamburger. This just sounds like I'm making a delicious meal. Let's take out the residual gradient from that image. So there's 3 back. MGC3628. So this is another quick and dirty stack. So there you go, there's the hamburger galaxy. Quite a lot of residual hot pixels in that one. Not sure why, but I'll try to clean that up later. Yeah, not too bad for less than an hour worth of light. I mean, that's pathetically little for most astrophotographers, and myself included. But just as a quick look at a couple of distant galaxies, I think it's pretty good. And I hope I've not given too many people the midnight munchies here by continually talking about hamburgers, but there you go. It does have a vague resemblance to a hamburger, doesn't it? Thanks, Dan. Alright, well, I'm going to put on some outro music here and wish you all a very good night. Thanks for watching. Clear skies, folks.